The Milky Way contains up to 400 billion stars. Yet for every single one of those burning suns, the math suggests there are multiple starless planetary bodies drifting silently through the dark, empty spaces in between. Astronomers call them rogue planets. By strict definition, these are interstellar objects with the mass of a planet, but they are not gravitationally bound to any star. They drift entirely alone. Their existence presents an immediate mechanical contradiction. Planets form within the orbital disks of gas and dust that surround young stars. Finding a massive world drifting freely through interstellar space contradicts our basic model of how a solar system is built. It means our traditional map of the luminous galaxy is heavily incomplete. It is hiding a massive population of exiled worlds. To understand how they end up in the void, we have to look at the chaotic spatial environment of an early protoplanetary disk. In these stellar nurseries, massive gas giants and smaller rocky worlds are forming close together, frequently crossing each other's orbital paths. This is what physicists call gravitational scattering. When these orbits intersect, a massive gas giant causes a chaotic transfer of orbital kinetic energy to a smaller rocky planet during a close encounter. If the smaller body absorbs enough of that kinetic energy, it breaches a critical gravitational threshold known as escape velocity, the exact speed required to break free from the host star's gravitational grip. Stripped of its orbit, the smaller planet is violently flung outward. It leaves the warmth of its host solar system for a permanent plunge into the absolute pitch-black space of the interstellar void. Planetary creation is often a process of violent expulsion. The stability of our own solar system likely required kicking other bodies out, leaving billions of frozen worlds wandering the pitch-black void. Finding these planets exposes a severe limitation in observational astronomy. Traditional telescope optics capture electromagnetic radiation, like visible light or infrared. In the pitch-black vacuum of space, a frozen rock emits almost none of that. This forces astronomers to stop looking for light and start looking for gravity. They have to search for physical distortions in the fabric of space-time itself. Physicist Albert Einstein provided the mathematical framework to make this entirely possible. His work on general relativity proved that massive objects physically warp the space around them, providing a way to see an object that is otherwise invisible. A wandering planet might be entirely dark, but it still has mass. Its gravity is the only remaining signal it transmits across the universe. This diagram shows how astronomers capture that signal using a phenomenon called gravitational microlensing. When a dark foreground mass drifts in front of a distant light source, its gravity bends the light rays, acting as a physical magnifying glass. Detecting this requires a precise physical alignment. An Earth-based observer, the drifting dark planet, and the distant background star must all line up perfectly. When they do, the rogue planet's gravity warps the distant starlight around its edges. This creates a brief visual distortion, a sudden bright halo of magnified light known as an Einstein ring. Because this alignment is entirely left to chance and incredibly fleeting, terrestrial observatories monitor tens of millions of background stars simultaneously, waiting to capture these microscopic gravitational anomalies. These microscopic blips of warped light confirm the void is populated, and they force us to question if these dark wanderers are truly dead. On the surface, the rogue planet presents a thermodynamic problem. Without a host star to provide radiant heat, the surface temperature plummets to near absolute zero, seemingly eliminating the possibility of liquid water. But the absence of external stellar radiation does not dictate the absence of internal planetary heat. Deep within the core, radioactive decay constantly radiates thermal energy outward. If the planet has a thick outer shell of frozen water, this ice acts as a perfect insulator. It traps the internal heat, allowing a vast liquid ocean to exist beneath the crust. Permanent isolation from a star might actually protect a planet's internal energy, turning a frozen exterior into a planetary-scale thermal blanket. If you were to physically descend through the deep cracks of that dark, solid ice, you would eventually plunge into a vast, pitch-black subterranean ocean. Down at the very bottom, along the fissures of the planetary seafloor, tectonic activity creates what are known as hydrothermal vents. These are glowing red volcanic structures that constantly erupt in the absolute dark, discharging scalding water and rich minerals straight from the planet's mantle. We know from the depths of our own oceans that chemosynthetic, bioluminescent life forms thrive in these exact environments. They sustain themselves entirely by converting this internal geothermal energy into food, completely independent of sunlight. We assume that biology requires a sunlit, Earth-like world, but the mathematics suggest rogue planets outnumber stars. This means the most abundant environments for life may not be orbiting suns, but swimming in the lightless hydrothermal depths of these wandering ghosts.